Hi, welcome back to Moose Chemistry. This is thermochemistry and specific heat and heat of vaporization, lesson number 2. How many grams of ice at 0 degrees Celsius and 101.3 kPa could be melted by the additional of 2.25 kilojoules of heat? The first thing you have to do is change the 2.25 kilojoules of heat into joules of heat because we're using joules over grams. So we're going to go ahead and do that. So 2.25 kilojoules times 1,000 joules over 1 kilojoule, right? So that kilojoule cancels out, and that gives me 2,250 joules of energy. So now we're going to use the formula HV equals Q over M. All right, and now we're looking for our mass. So that's what we're looking for. Our Q value is going to be, of course, 2,250 joules of energy. And our HV, in this case, is going to be given to be 334 joules over grams. Now, where to get that number? That's a constant for grams of ice, okay? So now we're going to reorganize this to be M equals Q over HV. So M is equal to, of course, 2,250 joules over 334 joules over grams, and our mass is going to be none other than 6.74 grams of ice. Pretty darn snarly, I say. All right, let's go to our next problem. These are not that difficult. The next one is, how much energy is required to boil 25.7 grams of water at its boiling point? All right, so what do we know? Okay, well, the boiling point of water for the HV is going to be 2,260 joules over grams at 100 degrees Celsius, which is the boiling point of water. So I have my HV value. Okay, so our HV value is going to be 2260 J over G, right? Our mass is 25.7 grams. So we're looking for our Q value, which is Q, which is the question mark there, sorry. So we're going to set this up as, of course, Q equals M times HV. So Q equals 25.7 grams times 2260 joules over grams. Grams cancel out, and of course it's going to give us our energy, which is in joules, and it's going to give me 58,000 0.82 joules, and we want to make that into kilojoules. We just move the decimal 1, 2, 3 over. If you want to do that, and that would be 58 point, let's just round it off, 1 kilojoules. Pretty darn snarly, I say. So that's that problem. All right, we got one more problem. How much energy is released when 32.9 grams of steam is condensed at 100 degrees Celsius? Okay, what do we know? Well, we know the boiling point of water is the same thing as steam, so our HV value, of course, is going to be 2260 joules over grams. We're looking for energy, that's our Q value, and we have 32.9 grams for our mass. So again, we move the Q around to say for Q equals M times HV. So Q equals 32.9 grams times our HV value, which is 22.60 joules over grams. Grams cancel out, and our Q value is going to equal 74,354 joules. Or if you want to put in kilojoules, you can. That'd be 74.354 kilojoules. All right. Well, that's it for this lesson. You guys be snarly. I will see you back here at Moosing Chemistry.